Hi everyone, welcome back to Coding with Bharat channel. I know it has been a little while since I posted here, simply because I was not a little well throughout the last few weeks and was struggling to juggle with work and all, right? But now we are back and I hope to stay back for a long time and yeah, cover up all the topics of DSA, cover up some of the hard problems. My goal is to actually solve all the hard problems on this channel by probably the end of 1 or 2 years, right? So yeah, stay tuned with me and let's start with today's topic, which is in a way a continuation to Z algorithm that we have already covered, which is going to be on the KMP algorithm, which is also a string matching one. So let's get started. So KMP, or if I look at the full form, it's Knuth Morris Pratt algorithm. So these are the three people who actually came up with this algorithm, Knuth Morris and Pratt, or one people, I don't know. But yeah, KMP algorithm, which is used for string matching. So first, let's look at what we had learned in Z algorithm and compare it with how it is different in KMP, right? So if you remember basis of Z algorithm, let's say you are given any string, let's say abc, abd, let's again take abc, and let's say abe. Okay, so let's take this huge kind of a string. So in Z algorithm we used to complete and make a Z array or a Z array, right? What was the Z array? So for example, if I am here, it would look at the prefix from the start of the array and the prefix starting at this position and see how many characters match. So for example, here we said that okay, our A matches, our B matches, our C doesn't match with the D, so answer here is 2. So when I calculated Z of position number, this is 3, so Z of 3 would be equal to 2. So that was what was there in Z algorithm. Whereas if I talk about the KMP algorithm, it also creates an array which looks similar but is actually very different, known as the LPS array or the longest prefix suffix array, right? So essentially, if I try to see LPS of I, what would it mean? So let's say I am at this position, this position. Oh, it erased. Let me take the pen. Yeah. So at this particular position, so I would only and only first of all look at the string till this point, right? So only this string. Now I want to look at the prefix of the string as well as suffix of the string and find the longest which matches. So if I look here, AB is prefix as well as suffix. So if I try to find LPS of 4, this is position number 4, then it would in fact be 2. That two characters are such that they are in the prefix, like exact prefix and exact suffix as well. Similarly, if I take this kind of an array, actually if you look at it, right, what would be the answer? So if you think about it, this is a palindrome, right? So our answer could have been 5. That okay, 5 characters from the prefix and 5 characters from the suffix matches. But LPS says we need to look at the proper parts only. We do not need to take the entire array. So if I think about it, even one length is prefix and suffix. If I look at two length, AB and BA, it is not the same. It is not the prefix as well as suffix. So 2 is not the answer. Then let's say 3 length, ABA, ABA. So again, 3 length prefix, 3 length suffix match. So 3 could be an answer. Let's look at the 4 length also. 4 length, ABAB and BABA. So they are not same. So 4 length is not the answer. 5 length could have been the answer, but LPS specifically only looks for proper parts of the string, right? You cannot take the entire thing. So actually, if you look at LPS of 0, 1, 2, 3, 4 here for the second string, then the answer would be 3. That okay, 3 characters in the prefix match 3 characters in the suffix. So that is the main array created in KMP. In Z, it was like you are at ith position, look at the characters after I and match it from the start. KMP says you are at ith position. The answer for this would be the longest suffix from here, which also matches the prefix, and it should be proper. It should not be the entire string, right? Even if it's a palindrome. Cool. So that is the LPS array. So how do we compute it? Simple idea. We can start looking for 1 length, 2 length, 3 length, 4 length, all the lengths, and try to bring those strings and match them, right? So if I try to write a small pseudo code for the brute force way of doing it, it would go something like, I'll calculate the result for all the values from 1 to n. By the way, for 0th position specifically, because it's a proper part, so LPS of 0 has to be 0. It cannot be anything else, because if I take even one character, then it's the entire string, right? So LPS of 0 by default is 0. So we just compute the results for 1 to n. So if I'm at 1 to n, any position, then I need to look at 1 length, 2 length, 3 length up to I length, right? Up to I length. So if I'm in position number 1, I cannot look for 2 characters, because 2 characters would mean entire string. So I'll go another loop for length. So length equal to 1. So 1 length will start with length is less than equal to I. We can take up to I length, not more than I length, and length plus plus. So we have 2 loops, one for the position for which we are calculating, one for length. Now we look at the suffix and prefix of this length and check if they are same or not. So if my string from 0th position till length of the characters is equal to string from till I and taking length characters in the past. So string from I minus length, you can say, till I. If those two match, if those exact strings, substrings match, then your answer could be length. Otherwise, you will ignore this and try to find a better length. So you can say LPS, if this it becomes true, so LPS of I might become equal to length, right? But it could be improved with a better answer in the past. So that is the simple brute force way of computing LPS. So if you think about the time complexity, this is in fact going to be n into this comparison is also n, because it's a substring comparison. So we'll be matching every character. So this is in fact going to be n cube. Okay. So that is the main idea of KMP. For calculating LPS at any position I, you look for suffix which is same as the prefix, the longest one, and which is not proper. Which is proper. Cool. So this is about KMP. I'll talk about the optimization. Before that, let me also figure out how we'll compute actual string matching like we did in KMP using this algorithm, right? So let's do that. So for example, if I want to see where all is ABC in a huge string, let's say ABD, ABC, ABCD, right? ABC, something like this. So what you would do, you would again use the same idea. You would put this in the beginning with a dollar. Now, if at any position you get the answer as 3, that means 3 characters match with the 3 characters in the beginning. So this is the end point. Remember, in Z, wherever the Z of I was equal to the length, that was the starting point of our substring. Here it is the end point of our substring which matches with the start of the actual pattern, right? Okay, so let's try to optimize our KMP from ON cube to ON, right? So for that, what I'll do is I'll take up this string ABC, let's say ABCD, then let's take ABC, ABCA, right? And let's try to compute the LPS for our entire string, right? So LPS of 0 is 0, B also doesn't match, so 0, C, neither C nor BC matches with the prefixes, so answer is 0. For A matches with the prefix and suffix, so answer is 1. So now when we are at B, again AB matches with AB, so answer is 2. Okay. Now let's concentrate. Let's look at the C now. Okay. So when we get this new C, the original idea was we'll look at all the lengths of size 1, 2, 3, 4, 5, so on and so forth, and see if prefixes and suffixes of that length match or not, right? But if you think about it, we already know two of the characters before this C match with the beginning. Now, the answer for this can be directly 3 if the third character matches with this particular character, right? So if the next character in line C matches with this C, which matches in this case, so answer will automatically be +1, which is 3. So with this, we can optimize a little bit, right? So first thing that we can do is we can directly compute the answer as +1 of the previous if the new character matches, right? One question that might come to your mind is, can the answer be more than this 3? Like, can 4 length or 5 length not match? But just think about it. If at this point last 5 characters were to match, then removing this fifth character, 4 characters should match with the first 4 characters as well, right? So the answer for this previous one should also have been 4. So if you actually think about it, what I'm trying to say is that answer for any I, LPS of any I, can at max be LPS of I minus 1 plus 1. One more than the previous LPS. Why? Why it can never be more than that? Because if it was more than that, then for the previous one also more characters would have matched. Okay, so that is one optimization that we can do, which is to cap it to the maximum number of characters that we match. Okay, but now the question is, what if it doesn't match? So let's take an example. Let's go to this D wala case now. So here if we see the fourth character is D, it should have matched with this A, but it doesn't match, right? Now how do we go about doing it, right? How do we go about doing it? So the answer for that is, then you have to look that, okay, this D didn't match, but the previous part of it which actually matched, is there some subportion of it which is also equal to the prefix, right? So the answer is no here, so we'll put 0. I'll explain this when it can happen in the following few steps, but the answer for this becomes 0. Again, A, first character matches, answer for the previous is 0, so first character matches, so answer becomes 1. For B also, second character matches, so answer becomes 2. C also, third character matches, answer becomes 3. A also, fourth character matches, answer becomes 4, 5, 6. So if you see, these are all the cases where the character matches with the new character which was to be added. Now let's look at this A. So we are saying this should be the 7th character in our line. So let's go to index number 6. 0, 1, 2, 3, 4, 5, 6. So ideally this A should have matched with this D. But it doesn't. Right? It doesn't. So can we directly put 0 here? The answer for that is no. We cannot directly put 0 here. Why? Because the portion which matched ABC, if you carefully look at it, it is also composed of 3 length suffix which matches with 3 length prefix, right? So still what we can do is we can try to match going a little step back, right? So let's see how do we go that much step back. So if we think about it, this C, which is just before D, has answer 3. That means 3 of the characters are same, right? And this C would also be same here because these are the characters which actually matched from the beginning, right? So now I can go back to where this last character was matching in the prefix and start counting from there. So this is at position number 3. So I can actually go back to position number 3, right? Which is after the third character, try to match the fourth character now with the new character that we have in our string. So actually, if you look at it, I go to the position number 4, which is this A, and match it. So it matches, so answer becomes 4. So idea, for calculation of any particular I, you first look at I minus 1. If the I minus 1, whatever the value is, let's say the value is 5. So now you try to match it with the sixth character in the array. Like 5 characters already match. So let me try with the sixth character. So you go to position number 5, which is the sixth character, and see if it matches. If it does, you just put the value as +1. If it doesn't, then for these 5 characters that match, you try to see, is there, like this fifth character, is it also made of some suffix which matches the prefix? If yes, then let's go back to that suffix. For example, here ABC which was there had a suffix of size 3 which matches the prefix. So what did we do? We try to see, okay, where is this C of it, and try to match from there. Okay, let me put it in terms of code as well. So how will we go about it? So what I'll do, I'll run a loop same as before, I equal to 1 to n, right? First thing that I do, I try to find which character do I need to match. So for that, what I'll do is I minus 1's LPS. I would look at that. So if LPS of I minus 1 is 5, I need to look at the fifth position only. So I'll say the position to be matched, or let's call it J for simplicity, is LPS of I minus 1. Right? If jth character now matches with your ith character, right? Then that means it's the next character in the line. So if my s of I matches with my s of j, so what is this case? So if you think about it, this is the case of, let's say, this C. So we look at, so this C. So we look at LPS of I minus 1, which is this 2, position number 2, which is this C. So if S of j matches with S of I, then that means this is the next character in line and I can directly do +1. So if my S of I is equal to S of j, then I'll directly say my LPS of I equal to LPS of j minus 1 plus 1. Right? Sorry, not LPS of j minus 1. We have put it in j, right? So simply j plus 1. Cool. So this is the first if case, that if the new character is the next character in line, I can simply do, if S of I is equal to S of j, LPS of I is j plus 1. Otherwise, we need to start going back. So otherwise what I'll do is, so let's go for else. Else, what I'll do, so till the time j is greater than 0. So first of all, j should be within limit. If it has already become 0, that means we are at 0. So we need to put 0, right? So when till the time j is greater than 0 and my s of I doesn't match with my s of j. So till the time I'm trying to go back and the character do not match, then I need to go back. So how do we go back? We look at one previous and its LPS. So I'll simply say j minus minus to go one step back. So when D did not match with A, so you go one step back to the last C which matched and go to its LPS. So j minus minus and finally j equal to LPS of j. So using this, you keep on going back and finally if a character matches, then you put your value there. So again the same thing, if the character has actually matched, if s of I has matched with s of j, then you again put LPS of I as j plus 1, right? So this is the code that we can write. I'll give the complete code also. So actually I have solved one question to it also where I have the complete code already written. So I'll quickly share that. But just to understand the idea, step 1, answer for this is previous plus 1. Answer for this is previous for 1 plus 1 only when your new character matches with the next character in line. If it doesn't, then you look at whatever matched so far and try to see if there is a suffix here which matches with the prefix, and you go back to that position till where that suffix matched for the remaining string, right? So that is the main idea. Cool. Let me go to a question as well, and let's quickly look at it as well. This was a direct question on KMP, which is longest happy prefix. So it says a string is called a happy prefix if it's non-empty. So it is a non-empty prefix, and that prefix is also suffix. So simple idea. We want to find the longest part of the substring which is also a prefix and which is also a suffix. So this screams KMP because we just need to look at LPS of last position, right? Whatever is the LPS of last position, that is the maximum suffix which matches with the prefix. Okay, so that was the main idea. So what I've done, I have written the compute LPS. Let's look at this function. As I said, I have declared this LPS array with all zeros. LPS 0 is always 0. So we'll not go to 0, we'll start with 1. So I've iterated my loop from 1 till the end. First, I've put j as p of I minus 1. So if you remember, LPS of I minus 1 told me the position where the next character is supposed to match. So if the characters match, then I directly put p of I as j plus 1 and continue. So simple. If the new character in line, which is jth character, if the new character in line, which is the ith character, matches with till the point this previous one match plus 1. So that is the jth position, right? If that matches, then answer is plus 1. So p of I equal to j plus 1. Simple. Otherwise, I'll run a while loop and start going back. So till the time j is greater than 0 and the characters do not match, I'll do minus minus followed by LPS of j. So minus minus because why? Because this was the character that we were trying to match, but it did not match. So we go to the last character which matched and see the longest suffix which was same as prefix and go to that point. So j minus minus for going to the last character which matched, and j equal to p of j for going to till where it actually matches. So that is the idea of this while loop. And then now if running after this while loop, if characters match, remember here also what can happen is j becomes 0. J becomes 0 and the character do not match. So there we want to keep 0 itself. Like for example, d is there. We keep on going back, but last character also a doesn't match. So we'll still put 0. So this condition is important. If actually the characters matched, then we would put as j plus 1 here. And finally what I've done is, because of this question, it wanted you to find for the entire string the longest prefix which is also a suffix. So I've simply returned the result of p of s dot size minus 1. So last positions LPS. Okay, that is the compute LPS. So finally, if you see here what I've done, I've simply done s dot substring, take the substring starting from the 0th position and length equal to the LPS of the last position. And as you can see, like while submitting, I can get it accepted. Okay. Let me show the test results as well. Yeah, it would show here accepted. Cool. So that was about KMP, specifically about LPS array, how to compute it. Let's also talk about one last thing. How is it O of n? Because it looks like we are running two loops, right? There is a I loop which goes and there is a j loop which comes back. So how is it O of 1? So the reason for it being O of 1 is, if you think about it, every value is just one more than the previous value, right? That is ensured. It can never be 5 times more or 6 times more than the previous value. So LPS of I just changes by plus 1 plus 1 plus 1, right? So if you think in terms of two pointers, this maximum value that we have achieved goes up till a certain point and then it goes back. Then it again increases by plus 1 plus 1 plus 1 and then goes back. So actually the number of increments that are going to happen is just going to be O of n. And even if half of them are increments and less are decrement, then it will not be a lot, right? So actually, if you think about it, it is actually contracted in O of n because of the simple idea that our maximum LPS value will just increase by +1, right? So even coming back is just going to be a fewer steps, which is equal to the LPS till that particular point, right? Also, one more thing to look here. Whenever you go back, so for example, let's say you started with LPS 10, you go back, you go back, you go back, and your LPS now new is, let's say, 1 or 2. Again, it starts with 2 plus 1, 3, 3 plus 1, 4. So you have less scope of going back. So because of this idea, at the end of the day, you are just going to slowly increment plus 1 in most of the cases, and the complexity reduces to O of n. Cool then. So that is about KMP algorithm. It's a complex algorithm, so it's perfectly okay if some of the things went above the head. Important things to make a note of: what is LPS? What is the LPS of I actually storing? Right? Second, what LPS of I is storing? How would you use it in normal question? For example, in this longest happy prefix question, it was more straightforward. In some of the other questions, using this LPS array could be a little complicated. Cool then, if you have liked the video, just subscribe to the channel and like the video, right? And yeah, so we have covered two approaches of string matching. Now my plan for the rest of the week is to take up some string matching problems from lead code and actually do them as part of some question practice on string matching. So do check out the Z video if you have not so far. And yeah, do implement Z and KMP both so that we can go over some of the string matching questions that are there in lead code these days. Cool then everyone. Good night. Bye bye. See you guys tomorrow.